Let's do number 17. The job placement service at a university observed the not unexpected result of the variance in market and work experience of the university's graduates. Some graduates received numerous offers, whereas others received far fewer. To learn more about the problem, a survey of 90 recent graduates was conducted, which they were asked how many job offers they received. Estimate with 90% confidence the variance in the number of job offers. The value from the sample is 4.72. So the variance of the sample, S square, is 4.72. Yeah. As I mentioned before, for chi-squared, the distribution is asymmetrical because we have here a natural boundary to the left, which is 0. Variance, as we know, can never be smaller than 0. It can be 0 when standard deviation is 0, but it would never be smaller than 0. But to the right, sky is the limit. It can be theoretically any value, but of course it becomes less and less probable. So we have here this asymmetric situation. And of course, the variance of everything, is different. So what we need to do is we need to kind of convert it. So essentially what we are saying is that we took a sample. The sample size was 90. We measured the variance, and the variance was 4.72. Now we need to convert that 4.72 somehow. The 4.72 goes kind of in the middle of this distribution, if you want. And then based on the assumption that 4.72 is here in the middle, I'm building here a 95% confidence interval, right? What would be the values of those 95% confidence intervals be? So what would be my lower confidence level and the upper confidence level for the variance? And essentially that's what we are doing here, right? So the lower confidence level, it's converting all that information so that the sample size was 90. S squared was the observed variance in my sample, and this chi-squared is essentially what is in the denominator is essentially how much of the tail do I want to cut off, right? Now, since I was looking for a 90% confidence interval, or it's, it means, it's an estimation, and I want to have it with 90% confidence, I have to cut off 5% to the left and 5% to the right. And implementing these values and calculating, what I get is that lower confidence level of 3.72. So cutting off the tail, the 5% tail, if the observed variance of my population was 4.72, it means the lower confidence level for my estimation is 3.72. And then we do the same thing for the upper, and that's happening here. Again, we use the same formula. However, in the bottom, now instead of taking the value for chi-squared of alpha half, we take the value of chi-squared of 1 minus alpha half. So if alpha was 10%, here we took 5%, we have to take here 95%, right? So which means essentially we are cutting off the right tail, the 5% on the right tail. So plugging in those values, degree of freedom is 89. We look here, and what we see is that there is no 89, right? There is no 89, there's just 90. And so 90 is the closest value to 89, degree of freedom of 89. So we just go with the 90. And then we are looking for the value of 95%, which is here. 69.1, right? And that's exactly, what I have here, 69.1. And, I do the math and calculate, and what I get is 6.08 for the upper confidence level. So with 90% probability, the variance of the population is between 3.72 and 6.08. So as you see, before, when it came to estimation of means, the lower and the upper level, so here was my sample mean, so X bar, for example, the upper confidence level and the lower confidence level, when it came to estimating the mean, had the same distance, right? So if, let's say, this was 10 and this was 11.5, this must be then 8.5. The distance, if this was 1.5, this must be also 1.5. Why? Because the distribution of the mean was symmetric, right? But that is not the case anymore when it comes to estimating variances. You see here, the distance is only 1, 372 to 472, but here the distance is more than 1 because the upper confidence level is 6.08, right? 6.08. If it would have been the same, then this would be 5.72 and not 6.08. Because as you see, the distribution is not symmetric anymore. So that's something interesting. I think it was worth mentioning.